All right, hello guys. Excuse this for a minute. What's up, Weather Dude? What's up, Sophie? Hey, Bo. What's up, Lost Craze Dude? Let me know if you can hear me okay. I'm using my standard um, setup for when I record videos. So if you can't hear me, just please let me know in chat. I don't have chat up. Well, actually, let me pull chat up here for just a second so that I can see all of you. Pop out chat. There we go. Okay, we're gonna put that on this side here. Um, yeah, I remember you, Weather Dude. I remember a lot of you. I don't do a whole lot of streaming these days, and I don't record nearly as much as I should. Um, but yeah, no, I remember you. Okay, so right now we've got this squall line setting up here throughout actually a lot of especially northern and eastern Oklahoma. We have this tornado watch that was just put into effect about 30 minutes ago. Um, Bo, I don't know how, I don't remember how you like to call yourself. Um, I saw the tornado warning earlier. I was unfortunately at work. I'm off work now, so I can actually cover this. I'm going to switch off from my MRMS radar over to my NexRad radar because you can get a lot more detailed with it. So, what's going on right now is if we can take a look, the squall line set up, and you can really see if we switch to velocity whenever the radar decides to cooperate here. There we are. You can see looking at velocity map, base velocity right here, just this line. There are some enormous winds sitting just ahead and just behind this storm system, this big squall line. Switching over to, okay, we're getting a new scan in right now. Um, Really quickly, actually, I'm not going to do that just yet. I want to let the scan come through before I switch over. I checked earlier. I didn't see very much in the way of rotation at the moment. I do see a couple of these notches, but unless we get an anticyclonic tornado, I'm not expecting these inflow notches to really produce anything. I have a couple of SKUTs from earlier today. Um, uh, Pulled up on my computer, and I will kind of discuss what's going on. Yes, it is a very healthy squall line. So we're going to switch over now to base velocity. And we're going to probe this really quickly. We've got 60-mile-per-hour outgoing winds just ahead, even as we go further north. Then again, these winds are higher up in the atmosphere because you're getting further away from the radar site. So the radar beam is further to the is further off the ground. So winds off the ground are going to be much stronger than they are on the ground due to friction. But wind shear is one of those things that you need in order to have real tornado development. Behind the squall line, which some people in chat are talking about it being a bow echo, it is definitely. I wouldn't call it a bow echo yet, but this could easily transform into a bow echo. And the reason why I say that is because with significant winds like that, you are going to have back end winds forcing the precipitation forward as you have the remainder of the squall line fall behind. Oh, what's up, Bill? Nice to see you dropping. I'm assuming that's Bill, but and howdy, Jacob, and how's it going, Jose? Jose? Sorry, I'm not great with pronouncing names. I am going to take a quick look here at this sounding that I've got from, I believe this is Little Rock in Arkansas. And so this tornado watch isn't all the way over toward Little Rock, but because this is moving in that direction, I did want to take a sounding from there. We'll actually move up to Missouri here because Missouri, this little corner, I believe that Springfield is under the tornado watch, so they will be getting this. What we have going on is we do have this cap right here, and the cap is going to be very important for tornado development because if you don't have that cap, basically you'll get what's going on right now is that there are all of these thunderstorms that fired up, and then they all joined together. And when they join together, they're all using collectively the energy. But if you have a cap right here, all that energy builds up beneath the cap, and so only storms that are that have sufficient energy will be able to really, happen. And so what happens then is that you have these storms that kind of explode into motion, I guess. But one of the things that we want to look at here is this lifted condensation level is fairly close to the ground. And so if we were talking about a real big tornadic situation, we want to see that LFC, the lifted free convection level, be very close to that lifted condensation level. But that's not what we see right now. But if that cap bursts, we may see that lifted free convection level buddy up right next to that LCL. And if we look at the hodograph on the side, we have a significant amount of speed shear and directional shear. So we've got 10 knots right here of wind at the surface, but then we go up to about we go just a kilometer up, and we've got 40 knots right here as a wind speed at about 1 kilometers off the ground. This could support a mesocyclone, and if you have a mesocyclone and you have that capping inversion, you are more likely to produce tornadoes. Now, what is limited right now is the CAPE. We look at the most unstable CAPE, we're only seeing 27 joules per kilogram. A lot of the convection that's happening is due to forced convection. It's due to that cold front pushing through, and not so much free convection, which is what you would see in a more tornadic situation. We have this is called the dew point depression, and if you've seen any of my recent videos, I've talked a little bit more about it because I'm learning right alongside doing this. This is a way for me to gain experience, but if we look here at about 6 kilometers up, we see that there's a very big depression here between the temperature, which is this red line, and the dew point, which is this green line. If we see this little blue line in here, this is called the wet bulb temperature sounding, and that's a calculated sounding. And basically what wet bulb is, it's the temperature that the atmosphere would be if you evaporated enough water into it in order for saturation to occur. And so when you see this means that any rain that's falling from above is going to evaporate within this layer because it's so dry by comparison. And when that happens, it cools the environment around it, and cooler air likes to sink, so it will sink to the surface, and then it will form as wind. And so this was taken at 12 UTC, 12 UTC to Eastern Standard Time. That's 7 a.m. What? I must have old soundings. Here we go. This is the one that I should be looking at. This may tell a much different picture than what we were looking at earlier. We're in... I need to check chat really quickly. Hey, everybody be safe too. Here we go. Okay, so the cap is as of... What is 0 UTC? Is that like 5? I think it's like 7 p.m. Eastern Standard Time. What is going on here? 0 UTC. Can't be 7 p.m. Can it? Oh, this is from yesterday. Okay, so I see what's going on here. 28. Okay, so no, this was right. Sorry about that. I'm just trying to figure this out. 12 UTC. Okay, so these were taken at 7 a.m. There was a special sounding taken in Oklahoma at 6 UTC. That's earlier. Okay, we're not going to worry about that. I see what's going on now. Okay, so going back to this. Yeah, okay, this is the sounding that we want. But this dew point depression, as I was talking about, generates some significant wind, and so there may be it may be pretty windy right now in Missouri. And this also is an indicator, if we take a look at the wet bulb temperature here, this is also an indicator of hail. Now, precipitable water right now is at 0.84 inches. We're not really worried about precipitable water at the moment because the precipitation hasn't made it to Springfield, Missouri quite yet. Now, as we're talking, we've got a severe thunderstorm warning that's popped up here for Cherokee County and Crawford County in southeastern Kansas. And it's for 60-mile-per-hour wind gusts. There may be damage to roof, siding, and trees. If we take a look at velocity here, this is fairly high up in the atmosphere, so I am going to move radar sites really quick. See if we have anything a little closer. Is that about? That's probably equal distance. We'll take a look at this and see if we can see anything else. We'll wait for that scan to come in. We'll take a look here. Okay, here we go. Elijah, I make my maps in, I use Photoshop primarily, but I use WSV3 as my radar software. So, okay, let's take a look here. We've got some range folding. We'll go to probe. So we're seeing this is still kind of high up, I think. Just behind the storm, we are seeing, hello. Oh, the scan's going, but, I don't see a possible tornado in this bow. Well, there is a little bit of what could be rotation there. That's a solid point. Let's run over to KINX again. This is going to be in North Miami at 5:51 p.m. This is all in Eastern Standard Time, so we have to convert this to Central Standard Time. 4:51 p.m. for North Miami, 4:52 for Commerce, 4:57 for Pitcher, 5:01 for Columbus, 5:07 for Cherokee. Let's see here. We're going to close out of that. I'm only seeing what could be rotation on this Springfield radar here. Is there any other radar kind of close? Okay, I'm going to look at this KEAX radar, and we'll see if that can be corroborated from that radar. Any storms coming towards Joplin? Yes, there is. There is this severe thunderstorm warning right here. It's from it's due to damaging winds 60 miles per hour. And so that's what I'm taking a look at right now. Is somebody said that, and we're awaiting activation. Okay, somebody said that there is a possible tornado here, but I want to check multiple radar sites to see if I can see rotation, because that will tell me whether or not there is basically rotation. If I can just get this scan to come through. Come on, you can do it. My internet's not the best right now. It's a lot better when I'm at school, but I'm at home right now for holiday. There we go. Well, there might be some rotation in this. We are kind of high up in the atmosphere, but there may be rotation in that. We'll take a look at reflectivity. We've got a nice squall line set up here, but this is further north than that tornado warning down to the south. Hail is not a big threat in this, just so you guys know. The primary threat right now is wind and tornadoes. Wind being the bigger threat, which I believe caused that slight risk. But then there's also a hail threat. Sorry, not a hail threat, a tornado threat, which is it's a less of a threat than the wind threat. But that being said, it's still there, and it was enough for them to put a tornado watch for a large chunk of area, mainly spanning north to south through Kansas, Missouri, Arkansas, and Oklahoma. Gonna try to figure out. We just got a new scan in, so we'll take a look here. The one thing that I could see happening here is this being a bookend vortex. And if this is a bookend vortex, that could provide the rotation needed for tornado development. And I think that may be why they put the tornado watch around here. They weren't very descriptive in their watch details or in the mesoscale discussion. But what I'm assuming is that they're expecting this to kind of transition into a bow front. And then when you have a bow front on the north and the south end of that front, you can get rotation just from the sheer force of the wind behind essentially curling the precipitation in the on the edges. Are we doing voice chat? No, I don't do voice chats on stream. I mean, I guess I could, but that's not what this was for initially. But we can take a look at the watch information. Like I said, there is a severe thunderstorm warning there now. They may actually show it on here. No, they're not going to. Okay. They've put a moderate risk for tornadoes within this watch box here. There was one tornado warning earlier, and that was further back in the Tulsa area. I believe it was the Tulsa area. I'm pretty sure it was. Was it Tulsa? Yeah, it was near Tulsa. It was near Tulsa and Broken Arrow. Sorry if everything's kind of smashed on screen. But yeah, in their watch information down here, they just say a fast-moving line of thunderstorms over eastern Oklahoma will track across the watch area through the evening. The strongest cells along that line will pose a risk of locally damaging wind gusts and isolated tornadoes. The watch area is approximately along 55 statute miles east and west of a line from 60 miles north-northwest of Springfield, Missouri, to 40 miles west-southwest of DeQueen, Arkansas. For a complete depiction of the watch, see the associated watch outline updated above. A tornado watch means conditions are favorable for tornadoes and severe thunderstorms in and close to the watch area. Persons in the area should be on lookout for threatening weather conditions and listen for later statements and possible warnings. If we take a look at the mesoscale discussion, all that they say is an elongated corridor of convection roughly 400 miles long and strongly forced currently extends from north-central Texas into southeastern Kansas. Some of this activity has evolved into short line segments within a more extensive squall line that is shifting east at roughly 30 knots, although smaller bow-type structures are moving considerably faster in excess of 40 knots. Over the last hour or so, lightning flash rates have decreased considerably within a weak instability environment. It's not clear when or if the squall line will re-intensify, as buoyancy downstream is not appreciably different than the environment this activity currently resides. We'll continue to monitor the strong forced squall line for potential upward evolving wind threat when or if this occurs. They only put it at a 40% watch issuance, but that being said, they did end up doing that. I'm gonna see if they've updated this, if we've got any more. They do. Okay, they do. I started streaming almost right as they did this, as they updated this stuff. So let's see if they say anything else. Okay, so they're not being very descriptive in what's going on. They're saying that areas to the south have a higher risk for this, but we're using old sounding, so maybe I can take a look at the HRRR model. Wait a minute. total weather. We'll go to models. We'll take a look at the HRRR model. And we'll look at 21Z here. We'll go forecast loop. And really, we'll just take a look at the sound, the projected sounding right now. Okay, so what this is showing is an LFC and an LCL that are close together and relatively near the surface, only about half a kilometer up, which is the type of environment you want to see thermodynamically for tornado development. The higher up that LCL and that LFC are, and the more spread out they are, the higher the cloud base is, and because of that, you're not going to have tornadic activity because that needs to be connected to a circulation at surface level. We do see, looking at this photograph here, we once again have that strong speed shear and that strong directional shear. We don't have much of a cap, which is really what we're seeing right now. The storms have pretty much broken the cap, as somebody said in chat earlier, because all of these storms are firing along this line, and they were likely broken due to that cold front moving through and forcing everything above the cap. Okay, we're going to take a look at radar again because I haven't looked at that in a minute, just making sure there are no other tornado warning or severe thunderstorm warnings. We still have this severe thunderstorm warning here in effect until, when does it expire? I guess this does say tornado possible in it. Hail is almost a non-threat. They made mention to the fact that until 5:30 CST. They made mention of the fact that lightning was becoming a non-issue, that lightning was really subsiding within these thunderstorms, and that's a good way of determining whether or not there's going to be hail, because in order to have lightning, you need to have ice in the clouds. If you don't have that ice, you can't generate an electrical charge, and so you're not going to have lightning. So the more lightning you have, the more likely you are to have hail, because you do have ice. But because that lightning that lightning threat is going away, we can be pretty safe in saying that. We can be pretty safe in saying that the hail threat is going down considerably. Take a look at chat here. For the most part, they're all situated here. If we could get that radar scan, they're all situated here in eastern Oklahoma. They're about to move into this Arkansas and Missouri area. We're going to take a look here at velocity. So the rotation that was there has gone away, and for those of you who don't know how to read velocity maps, we can take a look here at this wave pattern that you see right going straight through the radar site. We can tell that this storm is moving at a north-northeast way because the storm will move perpendicular to this kind of line that's set up here. All of these greens are inbound winds, which means that they're moving toward the radar, and all of the reds are outbound winds. That means that they're moving away from the radar. We can tell if there's rotation through stuff where they meet. If they're moving past the radar, it's likely not rotation. It's likely that they're just the winds are moving past the radar site, essentially. But these inbound winds here would be moving toward the radar, and these outbound winds would be moving away from the radar. So in this case, the inbound are moving to the north-northeast, and the outbound are still moving to the north-northeast, but it's just a way to differentiate what is what, really. You can get small circulations, though, when you have areas of intense wind and areas of non-intense wind. Basically, you've got stuff going very quickly in one area and stuff that's not going as fast, and that can generate a tube of rotation, essentially, within the cloud. We're going to take a look at reflectivity again. The storms are beginning to move into the Missouri area and really starting to push out of the Kansas area. I yeah, the storms are currently moving toward Joplin. It was a terrible tornado back then. Um, just kind of watching to ensure that nothing really happens, and if it does, we're on it. Um, until we get another watch or warning issuance, I'm going to move over to this MRMS radar, which is just a national radar. But you can see how far this has moved. We started streaming here at, what did we start at? Started streaming at 5:30, just about 5:30, and now we're half an hour later, and that storm moved all the way from this Tulsa area over near the border between Kansas and Missouri. I'm gonna make sure. Okay, I've got. Give me just a second, guys. I've got to go for a minute, you guys. I will leave the radar up and running. It will be constantly updating, but I should be back in 20 to 30 minutes, so I will keep this going here.